useEffects serve as an escape hatch when you need to step outside of React's direct control in your components. A common use case for useEffect is handling asynchronous requests like state updates, synchronizing external systems, data fetching, API calls, etc. In this tutorial, we will make a stopwatch, and I'll cover some of the important concepts like cleanup functions, dependency arrays, memory leaks, and implications of React's double render in development mode. Before we begin, let's take a closer look at this timer. If I click Start, the timer starts. You will also see there's a new Chuck Norris joke. If we wait 5 seconds, you can see that we have a new Chuck Norris joke. Now, Chuck Norris jokes aren't my favorite, but I didn't need an API key for this API, so that's why we picked it. I can press pause to stop the timer, and I can click reset to set it back to 0. For this video, you should already be comfortable with the concept of React state management. If you aren't sure what that is, you can check out my previous video where we build this candy jar. That video, along with the other 6 videos in this series, are linked in the description below. If you would like to follow along with the code from this example, you can get it from my GitHub repo. That is linked below as well. This is the code we will start out with in this tutorial. useState and useEffect will be imported from React. I've imported some CSS, and I made a card with placeholders where the time is going to be, and 3 buttons to start, pause, and reset. This paragraph is the placeholder for where our joke will render. To start with useEffect, I'm just going to show you the basic anatomy. We have a setup function as a callback for our first argument. The code that we want the setup function to execute goes here. There is the option for your setup function to return a cleanup function. We will get into more detail on this later. The final optional argument is a dependency array. I will also go into this in more detail later. For right now, I'm going to show you what happens when we just have this basic useEffect. Let's console.log hello. I'm now going to inspect my page, go to the console, and as you can see, we have a double render for hello and hello. If I refresh the page, React will do its double render again. This useEffect is called on every render of the component because it lacks a dependency array. This means that the effect runs after each render, including the initial render and subsequent updates. We're gonna just console log A. I'm also going to show you what happens when we have an empty dependency array, and we will console log B. When you have an empty dependency array, this means that the effect runs only once during that initial render and is not triggered by any dependencies. It ensures the effect is executed only when the component mounts and not re-executed on subsequent updates. To demonstrate how this works, let me add some state to our component. Start by adding some state. Whenever the useEffect for A fires, we are also going to console log the update state. I'm going to make an event handler called handle click. Actually, let's do handle reset. And we will update this update state every time this event handler is triggered, where the previous state value is now toggled to a new state value. And we are going to add this onClick handler to our reset button. Let's check out our code. I'm just going to re-render. As you can see, we have both useEffects firing on this initial render, and they're firing twice due to the React double render. And our update value is set to false. If I was to make our app bigger and I click reset, you will notice that our useEffect with the dependency array is not firing, and it only fired on that first render. That being said, our useEffect without the dependency array is firing, and it's showing that our state for update has now been set to true. I can click this multiple times, and as you can see, our useEffect with the dependency array that is empty only fires on that first render when the component mounts. If I was to reset this page, our component will remount, therefore we get both useEffects firing. Let's return to our code. You'll notice I just made our VS Code editor a little bigger because we're inevitably going to have errors as we write through the code, and I don't want that to distract. That being said, we are going to be constantly looking at the console, so I am keeping this visible. To implement our timer, let's get rid of these useEffects and this state and start from scratch. First and foremost, we're going to be starting and stopping the timer. On start, the timer starts, and then on pause and reset, the timer stops. So I'm going to make a state that keeps track of whether or not the timer is running. On page load, I'm going to default the timer running to be false. We also need to keep track of the time for our timer. And we will default the time to 0. Now let's update our handle reset event handler and add our start and pause event handlers. Set is running for reset should equal false. This is because when we click reset, the timer returns to 0 and stops. Therefore, it's not running. This also means we can set time to 0. Let's add our start event handler. Where set is running will equal true. When we click start, the stopwatch runs. Finally, pause. Set is running will equal false. We'll add these down here. There, I'm going to refresh this page. And at the bottom here, I'm going to console.log is running. As you can see, we start at false. If I click start, is running becomes true. Pause is running becomes false. Reset is running stays false. Start is running is true. React's useEffect cleanup function will save your application from unwanted behaviors like memory leaks. It does this by cleaning up effects before your component unmounts. It will also run right before your next effect executes. To demonstrate what happens when you don't properly clean up, I will show you what happens when you don't properly clean up after your useEffect. I'm going to make this useEffect, and I'm going to use the set interval function from JavaScript. Set interval takes two mandatory arguments. One is the function that we want executed. In this case, we'll do an anonymous function that sets our new time to the current time plus 1. This will happen every 10 milliseconds. And because we are dependent on time changing, I'm going to make a dependency array that has time inside. We also only want the set interval function to fire when the timer is running. So I will add is running to our dependency array as well. We will add is running as a condition. So if is running is true, set interval will fire, otherwise it will not. I click start, and now if I click pause or reset, and bam, we've got it. We haven't actually cleared the interval, therefore we're continuing to use up memory. To fix this, I'm going to make a variable called interval ID. This will keep track of the interval and can be cleared when the component unmounts or when our dependencies change. Assign interval ID to this set interval function. We will then clear this variable completely when we wish to unmount the component. So here is my cleanup function, and I'm going to use the built-in JavaScript function clear interval, and I am clearing this interval ID. I'm just going to refresh the page. We click start every 10 milliseconds, we are still getting information, but if I pause, immediately you can see the timer pauses, reset, we're still fine. Click start every 10 milliseconds, our value is updating again. We'll pause this for a moment so we're not seeing it flickering in the screen, and I'm now going to add a couple variables that are going to help us with the UI. So we're going to keep track of minutes, seconds, and milliseconds. Math.floor rounds the result down to the nearest integer. This is standard for representing minutes and seconds. By taking the remainder time over the number of milliseconds in an hour, which is 360,000, divide this remainder by 6,000, the number of milliseconds in a minute. Seconds follows a similar principle, taking time over the number of milliseconds in a minute, then dividing the remainder by 100, which is the number of milliseconds in a second. Finally, we will use math.round to round the milliseconds value to the nearest integer, because in the case of milliseconds, we want to be as precise and accurate as possible. This ensures that the milliseconds component is represented as a whole number rather than a fractional part, and we will take the number of milliseconds in a second and divide the remainder by 10. We will now replace these values with some JavaScript functionality so that the seconds actually reflect what we see in the time. Minutes convert to a string. We're ensuring that whenever the length of our string is less than 2, we pad the start with a 0. We're going to copy because we use a similar logic for seconds. And then milliseconds is a little different. Don't forget the colons here. And with milliseconds, we want to make sure that 10 gets represented as 0 as opposed to 10. We'll use the ternary operator to see if milliseconds equals 10, we make sure it's a 0. Otherwise, milliseconds to string is all we need. I click start now. You can see milliseconds and seconds are updating properly. If I pause, our time pauses. If I click start again, we resume where we left off. If I reset, our timer stops and goes back to 0. Let's return to our code. Now onto our final use effect that deals with an API call. If our timer is running, we'll use the fetch function to make a request to the Chuck Norris joke API. The response.json method extracts the JSON data from this response, and we will set the joke with our data. This just reminds me we need to add state for our joke. And we will set our initial joke to an empty string. Our condition will check if the number of seconds is divisible by 5. And the milliseconds component is 0. If this condition is true, that means that every 5 seconds, when the seconds value is a multiple of 5, and the milliseconds component is 0, we will fetch a new Chuck Norris joke. Get rid of our console log time. Let's take a final look at our app. I click start, our timer begins, and we get our first Chuck Norris joke. After 5 seconds, we get a new Chuck Norris joke. If I pause, we're not going to get another Chuck Norris joke. If I reset, we won't. If I click start one more time and we wait 5 seconds, you will see that we have another Chuck Norris joke.